I get a thumbs up at home that you hear me and see the board okay? All right. I just told the students in class that I have no written notes to give you guys today, but now that I have shown you guys the x-intercepts that repeat and their multiplicities and these bounces, I can finally assign you guys a homework on delta math. But before I send you to do work on delta math, I wanted to show you guys what your homework problems are going to look like, how you're going to do them. I don't like sending you into a new topic blind on delta math. So I created an assignment called Do Not Do This Assignment. Guys at home, you do not have to do this. But if you want to open it right now and follow along with me, that's your call. But if this is a 0 in the grade book for you, that's fine, because I'm not putting it in the real grade book. You are not expected to do this unless you want to follow along right now. All right? The only thing you are going to be expected to do is I did create a homework on delta math for you guys, but I don't think it'll post on your delta math until 5 minutes before this class ends, because I wanted everybody to let me try and show them before you try doing the actual homework. So this is your homework. It's 8 questions, and I didn't make it due until Sunday night. So you have today, you have tomorrow, and you have Sunday to try and get these 8 questions done. It's there? Oh, okay, good. All right, so here we go. So let me show you. I made 3 examples on this one. I'm only going to do the first 2. I probably only have to do 1. I just feel better doing 2. So here we go. I'm going to click on the first example. I'm going to show you what your homework looks like with these polynomial graphs. Okay. So guys, did I say something? Oh,
no, I feel like I was not like in his view.
Yep. So the directions say, sketch the graph of the function below, including correct signs. So guys, basically you want to make sure that your graph is positive and negative where it's supposed to be. You want to include x-intercepts, obviously, and they are asking for the y-intercept. If you don't cross over the y-intercept or the x-intercept, x-axis at the right spot, guys, you're not going to get marked correct. So please be careful. All right, let's go right to it. Let's set this function equal to 0. Let's start getting our x-intercepts. I do like to rewrite these factors that have an exponent on them. I like to expand that out. All right, it helps me get my leading term, and it makes me remember that I'm probably going to get more than one x-intercept from that. So that's really x plus 2, and there are 2 factors of it. All right, here we go. If I set this factor equal to 0 and solve, guys, you're going to add 2. You're going to divide by 2, and you're going to get x equals 1. So I definitely have an x-intercept at 1, and it doesn't repeat. So we're going to cross right over at that x-axis. All right, set this factor equal to 0, and I get 3, right? 1 time, doesn't repeat. That's going to be an x-intercept where we cross right over the x-axis. All right, if I set this factor equal to 0, I get -2, and I get -2 again. So that x-intercept repeated 2 times. So it has a multiplicity of 2, which is even, and x-intercepts with even multiplicity do not cross over the x-axis. They bounce. So I'm going to make a note to myself. Don't forget that he's special. He's going to be a bounce. He's not going to cross over. Now, it led with a -1. But guys, if you set a -1 equal to 0 and solve, you're not going to get an x-intercept from that. So you don't get an x-intercept from that. I saw some people literally taking -1 and using it as an x-intercept. No, you have to set the factors equal to 0 and solve to get an x-intercept. All right, I don't want to mark this up because I want you to see it on delta math, so I'm just going to draw a sketch over here to go off of. All right. We got an x-intercept at 1. And he's completely normal. We're crossing right over. We got an x-intercept at 3, and he's completely normal. We're crossing right over. I have an x-intercept at -2, but guys, he repeated an even number of times, so he's a bounce, so I'm going to mark him to remind myself that he's special. All right, now you want your y-intercept. Guys, look, you do not have a y-intercept at 0 this time because you don't have an x-intercept at 0. So your y-intercept is either up here or down here. You have to figure out where. So to find the y-intercept, x has to be 0. So let's plug 0 in. Let's see what number comes out. All right, so it starts with a -1, so I got that. Then you're going to multiply it with 2 times 0 is 0, minus 2 is -2. Times 0 minus 3 is -3, times 0 plus 2 is 2, times 0 plus 2 is 2. We got to multiply that together. So guys, some of your y-intercepts, they might be in the hundreds. Like, it could be a big number, all right? -1 times -2 is 2. 2 times negative 3 is negative 6. Negative 6 times 2 is negative 12. Negative 12 times 2 is negative 24. You definitely have a y-intercept down here at negative 24. Okay, now we got to figure out our end behavior, right? So we need that leading term. So let's multiply our fronts. So I start with a negative 1, and I times it with 2x. That's negative 2x. Negative 2x times x is negative 2x squared. Negative 2x squared times x is negative 2x to the third. Negative 2x to the third times x is negative 2x to the fourth, right? That's 1, 2, 3, 4 x's, and it leads with a negative 2. That's a negative 2x to the fourth, which means our polynomial is degree 4. So that's even. The end behavior for an even degree graph has to match, has to be the same. Both up, both down. If the leading coefficient is negative 2, which is definitely negative, which one is it? Both up or both down? Both down. So to the left of your last x-intercept, we have to end down, below the x-axis. Put a target. To the right of your last x-intercept, we have to end down, below the x-axis. Put a target. And then, guys, the graph should fill itself in. All right, now here we go. I'm going to start down here. I'm going to head towards my first dot. But, guys, my first dot is the guy that bounces, so don't forget to bounce. Go up, head towards it, but I don't cross over. I just bounce right off of him, and I stay below the x-axis. So now I'm going down. Guys, for all I know, maybe the graph goes all the way down here, turns, and hits the y-intercept on the way back up. We don't have to be that technical. We just want to make sure that the graph is still below the x-axis, and we are. So I'm just going to head towards that dot. All right? I connect that dot. My next one's up here. It's kind of quick, so I got to make it turn, go back up. Now, here's the thing that I'm worried about in delta math. I'm afraid you guys are going to make, like, wide turns. If you, turn and you're like, oh, crap, I should have been over there, and you try and come back, I think delta math is going to mark you wrong for this because you shouldn't pass x equals 1 until you've crossed over. And you've already crossed by going too far to the right. So try not to go past things. Otherwise, I think delta math's going to mark you wrong. All right, so watch your turns. You don't want to make them too wide, if you will. All right, so now we're going back up. All right, we're going back up. That x-intercept was a single, so we're crossing right over. Now I'm going up. I got a turn. And then that x-intercept was a single, so I'm crossing right over. And again, I don't want to go too wide where I have to come back. I can't pass this until I've crossed over. All right, I have no more x-intercepts, and I end down, so stay down. So that's what you want your graph to look like. So now you have to draw that on delta math using your mouse. Listen, it sounds easy, but what I don't like is, and I couldn't figure it out, maybe I'm doing something wrong, they don't let you click and put dots where your x-intercept and your y-intercepts are. So you don't have any dots to connect. You literally have to free draw this. And I don't like that because it's really easy to put your x-intercept at the wrong one. So please be careful. All right, watch me. I don't know, why can't we put dots? All right, so if I do this, right, I take my mouse, I'm ready. The minute you want to start drawing, just hold your mouse down and you're going to drag. Just keep holding it down. All right, so I have to start, where is it? To the left of -2. So to the left of -2, I want to be down here. So I'm going to start my graph anywhere to the left down here. I click, now I'm dragging. There we go. I got to bounce at -2. So I want to make sure I hit it and I bounce. Make sure you don't cross over. All right, now I'm coming down. I got to hit my y-intercept, right? Guys, my y-intercept is -24. You can see. It's counting by tens, so -24 ain't marked. All you have to do is make sure you cross the y-axis somewhere in between -20 and -30, because that's where -24 would be, okay? So just make sure you cross over in between the correct numbers, and you'll be good. But I got to make a tight turn, so I got to turn up, and I got to get to that 1. Now I want to cross over at 1, but guys, I don't want to. I almost went past it. You see that? I almost went past it. Oh, crap. Did I? No. Now I want to cross over at 1. And then I got to turn and cross over at 3. But I don't want to go past it until I cross. And then the minute you're done and you let go of the mouse, it automatically shoots these arrows on the end of your graph. And that's it. And then delta math is going to mark us right. I'm a little nervous about this, guys, that I maybe didn't do that nice enough, but I think we're okay. All right, submit your answer. Okay, so there it is. So now delta math does two things. It shows you what the graph really should look like. Let me get this out of the way. So clearly you can see that I probably didn't go up high enough or low enough. Dude, it's all right. We're good. We got the right idea. All right. Now above this, delta math shows another way to graph these problems. I taught you guys to graph them in what I call the quickest way. So long as you have your x-intercepts and your end behavior, the graph will fill itself in, guys. Another way to graph it, though, that they're showing you is they tell you to pick a number to the left and right of each x-intercept, plug it into the actual polynomial, and see if it spits out a positive or negative number. So this is showing you the sign chart, the sign analysis. It's saying if you picked any x value to the left of -2, a negative number comes out of that function, and your graph should be in the negative. And we were. If you pick any number in between -2 and +1, it's going to make a negative number come out of that function. So your graph should be in the negative. And we were. So that's just another option they're giving you. But guys, you got to sit there and you got to plug all these numbers in, make sure you come get the right number out. If you trust your end behavior, the graph fills itself in. So they're just giving you another option. All right, and then if you compare our graph to their graph, yeah, it looks a little bit different. But at the end of the day, guys, we're positive and negative in all the same spots. We were negative, we bounced, we were negative, we crossed over, we're positive, we went right through, and we're negative. So it's the same graph, all right? So that's what your homework's going to look like. I'm going to do one more just to give you one more look at filling it in, and then I'll stop, okay? All right, so let's do the next example, example 2, and then we'll call it a day. And if anybody finds dots, you let me know. All right, last one. Same thing. We're sketching it. Let's set it equal to 0. Let's start finding our x-intercepts, and let's do this. All right. I like to rewrite these factors that have an exponent on them, so I'm going to rewrite this as 3x plus 6 times 3x plus 6. All right? If there is an x with an exponent on it, I just figure I expand him out when I set it equal to 0. I'll figure that out in a minute. All right, here we go. Take your first factor. I'm going to do it over here. Set it equal to 0 and solve. Guys, think about how you make an x to the 4th. It's timesing x by itself 4 times. So now if I set all of these factors individually equal to 0, I'll get x equals 0 from him, 0 from that, 0 from him, and 0 for that. So you definitely have an x-intercept at 0, but guys, it repeated 4 times. That is an even multiplicity, so we will not cross over the x-axis. This will be a bounce. All right, then we get to set this factor equal to 0. That's easy. I get -6, and he's a single. We're going to cross right over. He has multiplicity 1. All right, if you set this factor equal to 0, you're going to -6, divide by 3, and you get -2. And you'll get it again when you set the next factor equal to 0. So you get x equals -2 2 times, which means he repeats twice, so he has an even multiplicity, and he will be a bounce. We will not cross over the x-axis. All right, let's put him on a rough sketch here. All right, we got an x-intercept at 0. And guys, he repeated 4 times. He's super special. That's a bounce. We got x equals -6. He was a single, multiplicity 1. We're going to cross right over. And then we got an x-intercept at -2. He repeated twice, so that's even multiplicity. He's going to be a bounce, so I'm going to mark him. All right, now my y-intercept. But guys, the y-intercept. If you have an x-intercept at 0, where does this graph automatically then cross the y-axis at? When y is 0. You already know your y-intercept. It's right there when y is 0. So you shouldn't have to plug 0 in to figure this out. You already know your y-intercept is when y is 0. But if you did plug a 0 into this, guys, I promise you, the 0 is coming out. All right, here we go. Now let's get our leading term. So x to the 4th times x is x to the 5th. X to the 5th times 3x is 3x to the 6th. 3x to the 6 times 3x is 9x to the 7th. This would leave with a 9x to the 7th, right? 3 times 3 times 1 is definitely going to leave with a 9. And then x, that's 1, 2, 3, 4, 5, 6, 7. There's definitely an x to the 7th going on. All right, which means this is degree 7, which is odd. And we know the end behavior for an odd degree graph has to be different. 1 up, 1 down. The leading coefficient is positive 9. So guys, if it has a positive leading coefficient, is it up on the right, the positive side of the graph, or is it up on the left, the negative side of the graph? On the right, the positive. So to the right of your last x-intercept, we have to end up above the x-axis, give yourself a target. To the left of your last x-intercept, we got to end down below the x-axis, so give yourself a target, and then it should fill itself in. Let's do it. All right, so I'm starting down here on this side of -6, and I'm heading towards that first dot. -6 was a single multiplicity, guys. We're crossing right over. All right, now my graph is going up. My next dot is there, so eventually I'm going to turn, so let's make it turn. And here's the thing. You don't want to make these wide turns. You don't want to go past it and have to come back. You don't want that. This graph should be on this side of that -2 until we get to him. All right, so I'll make it turn. When I get to -2, guys, -2 was a multiplicity 2. He bounces. We don't cross over. So we're going to hit him, and we're going to bounce right back up. This is tight. Now I have another x-intercept at 0. So eventually my graph's going to go up, but we're also going to have to turn. But guys, we don't want to make a wide turn. We don't want to go past him. So turn. Now 0 repeated 4 times. That's even. He's going to be a bounce. Don't cross over. So we're going to get there. We're going to bounce right back up. I have no more x-intercepts to head towards, and I should end up. So stay up. So we had a double bounce. Let's see if we can draw this. Do I have you? All right. So I'm where? I am starting to the left there at -6. I am bouncing at -2 and 0. This is the hard part, guys. This is the part that stinks. I wish I had dots. All right, so I'm over here. I'm heading to -6. Cross right over. Boom. All right, now I'm going up. I turn. I'm going to bounce at -2. Be sure to not cross over that axis. Bounce. I got a quick turn. I got to bounce again at 0. Don't go past it, though. Jesus Christ, that's hard. Bounce. I hope that didn't work for you, right? I don't know if I missed that. Here we go. Let's try it. Submit answer. Fingers crossed. Did you? Nick voted against me. Hold on. I did it. Wait, double click and it should go away. Okay. All right. You gotta have steady hands. You gotta have steady hands here.
This is where the dots would come in.
This is where I put it in. All right. Darn it. -6, right? We're bouncing at -2. Boom. We're bouncing at 0. Boom. You don't think I got it? Shoot. Shoot. I'm recording too. Nailed it! All right. I actually don't want to accept it because it was a second try anyway. But again, guys, so I do understand that you could easily get this marked wrong and be right. So please be careful. You get 2 tries on each graph. Keep that hand steady, guys. All right. But that's it. So that's what your homework's going to look like. It is due Sunday. It's 8 questions, and I didn't make it due until Sunday. So you could do a couple at a time, a couple a day, and be fine. All right? And then here's the plan for next week. We're going to come in Monday. I'm going to let you try deltamath again. I'm going to probably make it like a review. It'll be just like the homework you do over the weekend. And then I'm going to let you guys quiz on Tuesday. So if anybody comes into school on Tuesday, you do not have to take your quiz here. You can wait till you get home so it's fair like everybody else. It'll be your period on Tuesday in class. All right, but I didn't want to make it a quiz Monday. I wanted to give you guys at least a day or 2 to practice this deltamath before I make it a quiz grade, okay? All right, so here we go. That is the plan. So you have homework. It should be posted now, and I hope you guys have a wonderful weekend. All right, let me know if you need any help, and we will see you on Monday.